Good morning, everyone. Thank you for coming to my TED Talk, Tech Talk. So today I will be speaking about two of my passions, or one of my passions and something else very interesting, that is the union of Formula One and data analytics. So in a sport where 1 to 2 milliseconds can make you a world champion or not, and any small miscalculation can result in you crashing into a wall at 300 kilometers an hour. Every minute detail counts. So today we'll be looking at how Formula One teams have been leveraging the cloud, data analytics, as well as artificial intelligence to develop their cars and to maintain success on the track. Now, let's go over a brief history of Formula One. The first Formula One race took place in 1950. And as a fun fact, the first programmable computer, the EDSAC, was built 1 year prior in 1949. So this sport and computing in itself have been growing alongside each other ever since. Now, during this period, up until the 1970s, cars were purely mechanical devices. Engineers would have to design cars on paper and then build them and then test them. The cycle was repeated until the vehicles were refined and teams and drivers were satisfied with what they have. From the 70s to 80s, microprocessors and electronic components were becoming readily available. Teams use these components as sensors on their cars to monitor parameters such as your engine RPM, throttle input, and braking. And now these sensors allowed teams to gain a clear understanding of how their cars behaved on track and could adjust their setups and strategies accordingly. Now, due to the usage of floppy disks during this era, data was severely limited to about 1 lap's worth of data. Once the race was over, the information was downloaded onto computers in the garage and analyzed. This would be the start of the data-driven revolution in the sport. Now, before we go forward, I'd like to briefly talk about what a race strategy is and why it is so important for teams and drivers. Now, a race strategy is a plan that outlines what teams and drivers should do to maximize their performance and minimize the time and positions lost during a race. Now, teams will typically have 2 strategies prepared, known as Plan A and Plan B. Unless you're a Ferrari fan, then you'll have one for every letter of the alphabet. Now, modern strategies are developed by armies of strategists and analysts who use a mix of historical data and live information to try and predict possible outcomes of a race, as well as provide plans to follow in each event to maximize a team's chances of success. Now, during a race, it's mandatory for a driver to make at least 1 pit stop to change their tires. An average pit stop takes about 3 seconds to do. However, a driver can lose up to 20 seconds in the whole process. Now, teams must be able to plan the optimal time to do this based on multiple factors, including their driver's pace, the pace of their rivals, how their tires are degrading, how the other teams are performing as well, and including certain factors such as the track conditions and whether a safety car is deployed or not, or if there's rain expected and for how long. Now, as we can see, strategies are essential to minimizing the times and positions lost during these stops, as well as improving the team's ability to gain the positions during the race. These strategies are also updated in real time based on constant live streams of data from the race to ensure that they remain accurate and relevant. Now, as you can imagine, planning for hundreds or thousands or millions of scenarios in real time and providing this information to the teams at the track almost immediately is a mammoth task. Now, this is where Formula One teams have learned to leverage the cloud to support these demands. So let's speak a little bit about the cars themselves and how this process takes place. Now, a modern Formula One car has around 300 sensors, which measure everything from airflow to tire temperature to driver biometrics such as their pulse and oxygen levels. The sensors of an F1 car generate around 11 billion data points and around 3 terabytes of data over a 3-day race weekend. Of course, over the week leading up to the race, these teams will run millions of simulations using historical data to prepare their strategies. These simulations are run by deep learning models that have been trained to predict the outcomes for every race that takes place in a season. They are also used to predict future scenarios during the race using real-time data that they receive. Now, while out on track, The cars broadcast information using custom-made telemetry systems to the team garage, where the data is then streamed over a secure high-speed network to their headquarters in just a few milliseconds. More information is also downloaded from the cars back at the garage. Race engineers use the feedback from the factory to make calculated decisions on what actions the driver should take. And all of this happens in a few seconds to a few minutes. Now, let's discuss a real-life example, to pit or not to pit. During the 2022 Canadian Grand Prix, Max Verstappen is leading the race for Red Bull, closely followed by Carlos Sainz Jr. in his Ferrari. The safety car is then deployed on the fifth lap of the race due to an incident on the track. Now, this forces teams and cars to slow down to a predetermined speed, and they're prevented from overtaking. Now, the Red Bull team have to make a decision. Do we pit now or later? If the team pits under the safety car, it would reduce the time and position lost during the stop and fulfill the mandatory pit stop requirement, but it would mean giving up the lead position. Alternatively, the team could keep Max out on track and build a bigger gap between the cars behind him if they pit, but risk deteriorating his tires and slowing him down later. So what do you do? Well, the Red Bull team decided to run thousands of simulations before the safety car period ended. And considering the results from these simulations, they came back as confident that Max could win the lead back if he pitted now under the safety car for a fresh set of tires. So supported by these results, the team decided to take this risk and pit for a fresh set of tires while the safety car was still deployed. Now, as luck would have it, the Ferrari ended up staying out and struggling to maintain its pace on all tires. Verstappen was able to take the lead again. And this is just one example of how these live simulations are able to bolster teams' decision-making in order to take advantage of every opportunity on the track. Now, let's discuss how cloud computing is also used in the vehicle development space of Formula One. For small underdog teams like Haas, Williams, and Alpine with small budgets, the data-driven approach has helped them level the playing field with bigger constructors such as Mercedes, McLaren, and Aston Martin. As one can imagine, running these simulations and exercises require computational power. And due to the current cost cap, teams have leveraged cloud computing providers and data analysis firms to help them process the mountains of data they generate. It's just simply more cost-effective to build a car and test it virtually rather than building and testing a physical vehicle, which would make a big dent in your budget or may simply not be possible. Now, let's look at some partnerships between Formula One teams and cloud technology providers. So, Amazon Web Services is the exclusive cloud provider for Formula One, and AWS is also the cloud provider for the Scuderia Ferrari team. Other notable partnerships include Red Bull Racing and Oracle, Mercedes-Benz and Hewlett-Packard Enterprises, and Alpine with the Microsoft Azure Cloud. Now, this is not an extensive list, as each team utilizes some form of cloud computing provider and some type of analysis company to help them process the mountains of data they generate. Now, AWS is also used to provide the insights you see while you're watching a race. Formula One's data scientists use the Amazon SageMaker along with a host of other services to train deep learning models on over 65 years of race data. Now, we use this to extract statistics and make forecasts and provide fans with insights into the split-second decisions and strategies used by teams and drivers. Now, the FIA, which is the regulatory body that oversees Formula One, also uses AWS exclusively to develop their car regulations for each season, as well as support their ability to monitor teams during races to ensure that they comply with the rules and manage any disputes that may arise. Now, this brings us to the next evolution of Formula One. Where does the future look towards? We can expect exponential growth in the field of cloud computing, data science, and AI over the coming years. And we can be guaranteed that Formula One will fully utilize these technologies as they continue to push the boundaries of motorsport. By 2030, Formula One aims to produce net zero carbon emissions and only burn fully sustainable fuels, as well as increase the amount of electrical power cars will use. Adapting to these changes will require immense planning, development, and testing by teams hoping to gain an advantage in order to maintain their positions at the top. So the fusion of cloud computing, data science, and AI is poised to redefine Formula One as we know it. The data-driven revolution will not only lead to faster cars and more competitive races, but also contribute to a greener and more sustainable motorsport ecosystem. As we look ahead to the future of Formula One, it's clear that data analytics will be the driving force propelling the sport to new heights of excellence, innovation, and environmental responsibility. So fasten your seatbelts because the race into this data-powered future has just begun. Thank you.